Hi guys, today's notes and lesson are on day 4 notes, graphing trig functions with amplitude and period change. And yesterday you graphed sine and cosine with an amplitude change. Today we're also going to add in a period change. And so if you remember yesterday, kind of what amplitude did was it stretched it vertically. So amplitude changes our y values. A period change is going to change our graphs and how it looks horizontally. So it's going to mostly just affect our x values. Before we get into any other type of changes, we want to go back and look at our unit circle, because the way that we want to start this is always by looking at our unit circle and getting our mom functions correct. So if we're looking at this first one, like where did these dots come from? And typically there's 5 major points that you're going to graph, and then we're going to use that cyclical periodic function to go back and forth. So if we're looking at our graph, again, our ordered pairs are alphabetical, cosine, and then sine. And if we're starting off at 0 degrees, if we're trying to make our graph and we plug in for theta is 0 degrees, what is our sine function doing? Well, at 0 degrees, the sine is also 0. So that's where we get this first dot, 0, 0. And then if we rotate and go to 90 degrees, that's when our sine function is at positive 1. If we then rotate to 180 degrees, our sine function is at 0. And then if we rotate at 270 degrees, we're at negative 1. And then back to 360, we're back at 0. I ran out of a little bit of room. I'll nudge it over. 360, we're back at 0. So those are those 5 critical values that we see plotted here. And this is our parent function for sine. So if we're looking at y equals 1 times sine of 1 theta, like it would just be like y equals sine theta. This is our parent function. Nothing's going on. There's no stretching or vertical or horizontal change just yet. For cosine, here we're looking at those values for what is cosine doing. And again, we'd want that parent table. So our parent table here for theta, we still would have our from 0 to 360. That is our general function or mother function, parent function for cosine. At 0 degrees, we're at 1. So here we have that is the maximum value. And then it goes to 0 when we're rotated to 90. At 180, we'd be at negative 1. Now we've reached our minimum. Okay, so it starts off at its max, then it goes to the middle, and then it goes down to the min, and then it goes back to the middle, and then it goes back to the max. And both of these have that positive 1 for the amplitude. So that's where we see that function, and that's what it's called, its cycle. So those are some review terms that we're going to be looking at again today. So if we're remembering, the amplitude of our functions is the absolute value, because it has to be positive if we're talking about distances. That's half of that difference between the max and the min. And both of these have a maximum of 1 and a minimum of negative 1. So that distance is 2. So half of the distance of 2 would just be 1. And we want to make sure that we're only looking at a positive value. So our amplitude on both of these is 1. Okay. So it's the absolute value of half of the distance between the max and the min. And that's where we see in our functions here that we haven't multiplied by anything in front. And if we looked at, we said this is y equals cosine of theta. Again, the amplitude would be in front of the value, and it's just 1. Then we also have the period of the function. And the period of the function is this horizontal distance, so it's dealing with the x-axis. That's requiring the graph to be periodic, so it's going to repeat itself, but we would just want to see what one full cycle would be, like what makes it go back to where it started. So we saw on our sign that it started in the middle, and yes, it gets back to the middle, but that's not the full rotation. That was halfway. So it goes above and below and then back to the middle. So in order for it to create that entire cycle of those 5 points, the period was 360. And the period on our cosine is also 360. It starts off at 0, then it goes middle, min, middle, max. And so if we go back to where we started, after those 5 critical points, then we're back to one full cycle. So if they're positive, for positive sign, it looks something like kind of an N shape. And then for positive cosine, we saw something that was more of like a V shape. I don't know. And then if it's negative, it would just do the opposite. Okay. So it would start at a minimum and then go back to a minimum. All right. So in general, how are we finding those parent functions? All right. So now we also want to know how our function is going to change. So in general, the period of a function of the mom function, a normal cosine or sine function, completes that cycle we said after 360 degrees. Okay. But we can mess with that by changing our number that's attached to our theta or our x value. For us, amplitude is that number in front with an absolute value. So we can see a number that's negative or positive for our a value, but that's going to change our amplitude, how high or how low it goes. So our amplitude is always positive because it's dealing with a distance, and so we're going to have that formula as being the absolute value of a, but changes in the amplitude only are changing our y values. Okay. For the period, remember we said x is a liar? Well, instead of x, we have theta. You could easily write that as an x as well. But period changes are changing. Theta is like x. When we said x is a liar. So whenever we do something like it says b times theta, we're going to fix that by doing the opposite. But these are going to change our x values. And it's going to create a horizontal difference in our graph. So like we said, x is a liar. What that means is when it says b times theta, if normal is 360, we're going to divide it by b to figure out the period. Literally what this is saying is how rapidly it repeats. So if you've ever listened to the radio, I know most people only have like XM and FM, but we had AM and then we also have FM. So when we're looking at those sound waves, if something's changing the amplitude, normally we oscillate between 1 and -1 for our functions. If we go and we change the amplitude, now we're making it higher and lower, right? Now we're wiggling back and forth between different values of A. So that's our change in our amplitude. It's going to make it higher and lower. If we want to change the period, instead of it ending or repeating after a cycle of 360, whatever B is will create either more or less waves in that same amount of time. So we end up with like more squiggles or less squiggles in that same amount. And literally, if we have something like half theta in that 360, you wouldn't see an entire wave function, you would see half of a wave function. Okay. So as we go through and look at this, we're going to just change amplitude and period. There is another type of thing that we can change, and that's where the middle is. So for now, we're not having any type of up and down vertical shift. So the vertical shift right now is just going to be none. And the midline is still going to be 0. Okay, and then day 5, we'll deal with what happens if we put plus something on the end. Okay, so this is just practice of being able to identify the amplitude and the period of each function. So if we're looking for the amplitude, we're looking for the value in front of our function. And we're going to always make that positive. So the absolute value of 3 is just 3. So our amplitude is 3. The amplitude for the next one would just be 6. The amplitude of negative 1/2 is still 1/2. Okay. For the period changes, this is where it might be a little bit tricky because we have to do the opposite. X is a liar. So it says right now like 4 times X or 4 times theta. We're going to do the opposite. And if we know what our period should be 360. When it says multiply, we're going to actually divide. So in this problem, like A is 3 if we're thinking in general terms, and B is the 4. And our formula for amplitude was the absolute value of A. Our formula for period should be 360 divided by B. And since that value is 4, we're going to divide by 4. So this period would be 90. Okay. So the amplitude being 3 means this wave is going to wiggle back and forth up and down to 3 and negative 3. So it's going to go 0, 3, 0, negative 3, 0, because it's a sine function. But how fast is it going to do that in? Well, in 360 degrees, because you see 4 theta, in that 360 degrees, it's not just going to wiggle back and forth once, it's going to wiggle back and forth a total of 4 different waves. And my waves are pretty ugly, but you should see 4 of them. There's 1, 2, 3, and 4 in 360 degrees, where typically you'd only see 1 in that same amount of space. Okay. On the next one, we're going to use that formula again. Here, B is 5. So since B is equal to 5 in this problem, and our formula for period should be 360 divided by 5, our period here should be 72 degrees. Okay. So you're always doing the opposite of whatever's happening to theta. That's what we have for our transformation. On the next one, here, B is 1/3. So here we're multiplying by 1/3 or dividing by 3. So we would do the opposite. 360 divided by 1/3. If we think about fractions, that's the same as multiplying by its reciprocal. So instead of dividing by 3, we're going to multiply by 3. And that's going to come out to be 1080 degrees. So here it would take 180 degrees before you would see that full cycle of sine. And then we just have to be careful to pay attention when we are looking for our mom function. Are we dealing with sine or cosine to know what type of pattern to use? So that's what we're going to do next. We're going to look at those tables and see if we can actually graph one of these functions now that we understand how it works. Okay. So first we might want to start with our unit circle so that we know what we're dealing with. So this is at 1, 0. If you go up, it's at 0, 1. If you go back, it's at -1, 0. If you go down, that'd be at 0, -1. And the way that the order works is you would have cosine and then sine. So if my parent function is cosine, then I'm going to use my parent table first and fill in cosine typically for that mom function, we want to make sure that we're using our unit circle. Okay. So it goes the pattern 1, 0, -1, 0, 1. Now we're going to transform this mom function for cosine, and the way that we're going to transform our table is we're going to look at that amplitude. So we have to be careful. The amplitude is changing our y values. So that's going to change all of our numbers along the bottom, and we're starting with these numbers. The period is changing the x's, so that 2 theta is going to affect the period. So we're going to take these values for quadrantials, and then we're going to mess with them. So first we're going to look at what is the amplitude. That formula should be the absolute value of A. Here A is -1/2. So our amplitude would be +1/2. So it's going to go up and down, a total of up 1/2 and down 1/2. For the period, that formula should be 360 divided by B, and in this case, B is 2. So 360 divided by 2 is 180. So that's telling me that this entire cycle, we still start at 0, but it has to be done by 180 degrees. Whatever number you have here for your period should be where we're ending our table. We said that for today, we're not adding or subtracting anything out there, so it's just going to be none. And our midline is y = 0. So if we look on our graph, what it's telling you is that the middle line, there's the midline, and that is an equation. Yes, it is the x-axis, but we would say it's like y is equal to 0. And then if we're looking at our amplitude, we're saying we can only go up 1/2. So I'm going to build like a little road for us to follow. I can only go up 1/2 or down 1/2. Okay. And we have to repeat this entire pattern at least once by the time we get to 180. So if we go through and look at the transformation for the x values, if it says multiply by 2 by saying 2 theta, what we're actually doing is the opposite of that. We're going to take each one of these numbers and we divided them by 2. So 0 divided by 2 is still 0. 90 divided by 2 would be 45 degrees. 180 divided by 2 would be 90. And 270 divided by 2 is 145 degrees. Okay. And then, oh, sorry, no, it's not. It's 135 degrees. Me and math. All right, I think I fixed it. So that's allowing us to see that we're going to have one full cycle in half the amount of time. For our amplitude, even though our amplitude is positive, when we take these numbers for our y value, we are multiplying by -1/2. So we want to make sure that it's starting off negative. So because of that -1/2, we're going to take each one of these values and multiply it by -1/2. If you take 0 and multiply it by negative, it's just 0, but a negative times a negative would be positive. So it starts off negative and then it becomes positive. It goes back to 0. 1 times -1/2 would be -1/2. So because the function was negative, it's going to start down here at -1/2. Then at 45 degrees, it'll be at 90. Or sorry, at 0. At 90, it'll be at +1/2. Then at 135, it'll be back at 0. At 180, it'll be at -1/2. So again, this should be what our cosine function looks like, and we're going to have to fill in the rest of it, but that's just one single period. So that's one cycle around. So it should go, like mountain, valley, mountain, valley. So here's the mountain. We need to do the valley. It's just going to repeat again. So if we're down at the bottom at the min, then in the same amount of time, after 45 more degrees, we'll go back to 0. And then we'll go back up to the top, the middle, and the bottom. So this is what we mean by 2 theta. So there's one cosine wave. There's 2 cosine waves. And that's why when that number was 2 theta, we should see, like what does 2 theta do? In 360 degrees, we should see 2 of that cosine pattern. Okay. On the back side of this, we have to do it all over again. Make sure on the ends, like you don't go crazy. Like that would keep going up, but not up forever. So stay in the lanes. If you're going backwards, you would just do the same pattern, but backwards. Okay. So if you need to turn your paper sideways, like you should have an above and then a below, an above and then a below. And you don't want to have 2 mountains next to one another. Otherwise it looks like butt cheeks or something weird. Like you don't want to have 2 valleys next to one another. So if you're completing a valley, you need to go to a mountain. Okay. All right. Another trick for that I would say is if you're going backwards or counting backwards, like you can say like this is 0 degrees. And then if you go backwards, this would be negative 45 degrees. This would be negative 90 degrees, negative 135, and then negative 180. So if it helps you to start back at 0 and see like count backwards of these same exact numbers that you had, that can help because then you're just plotting those numbers. If it helps you to put in like 45 and 135 and count that way, you can count that way on your grid as well. All right. Here's the next question. So we're going to start off by saying what is the amplitude? The amplitude should be the absolute value of the number in front of our function. So the absolute value of 2 is just 2. The period should be 360 divided by the number in front of theta. So if we go through and take 360 and divide that by 1/2, we would end up with actually 360 times 2, which would be 720 degrees. Okay. Right now, because there's nothing being added to the back, our vertical shift is none, and our midline is the x-axis, y equals 0. For me anyways, at least this is what I do. Like I know now, like that's the middle. And then if I want to stay in my lanes, my amplitude is saying we can go up to 2 or down 2 from that midline. So if we know where the middle is, if we go up 2, that would be my max. And if I go down to negative 2, that will be my min. And we're going to wiggle back and forth between there. Well, how do we wiggle depends on that unit circle. So if we go back to our unit circle and look at the pattern for sine, here's my unit circle back there. My pattern for sine was 0, 1, 0, negative 1, back to 0. So sine starts at 0. So if we go through and fill in 0, 1, 0, negative 1, 0. Someone once told me, her name was Sarah Gallego, and she said she remembered that for sine, it has to have 3 zeros because it's like a snowman. So if that helps you to know that that's the one that has 3 zeros and not 2 zeros, that might be a way to figure it out well, but also just make sure, like, where are these numbers coming from? They're coming from my unit circle. All right. Then, since theta is our x and x is a liar, instead of multiplying by 1/2, I'm going to do the opposite. We want to make sure that we know that that last number there should be at my end value. So it still starts at 0, but we're going to multiply by 2. So all of the x values or the theta values are going to be multiplied by 2 here. That'd be 360 and 540. Okay. For our amplitude, amplitude's always positive, but we're going to multiply by whatever number's in front here to figure out our new y value. So since it says times by 2, I'm going to multiply all the y values by 2. So 0, 2, 0, -2, and 0. And then once we do that, we graph those. So at 0, we're at 0. At 180, we're at 2. At 360, we're at 0. And as you can see, we only have an above ground, like mountain shape. We don't have both pieces of our sine wave. Usually our sine wave should be like a mountain and then a valley, right? That's the mom function. We only see half of it because of that half theta, right? Half theta means in 360 degrees, you only see half. So if we go backwards, this would be 0 degrees, and then -180 degrees, -360, -540, and -720. We can see the negative values of that rotation. So we should know that if this was a mountain on the right side, I can't have another mountain over here. It would look weird. Like, that's wrong, right? Don't do that. Instead, it needs to do the other half. So if that's a mountain, I need a valley over here. At 0, we're still at 0, right? But at -180, we'd be down here at -2. And then at -360, we'd be back at 0. We see that other half, that frown, that's ugly. I'll try again. The magic of internet. All right. So that would be our other half of that sine wave. All right. These next few questions are matching. We want to practice changing the tables. Knowing these parent functions is super important. So when we see sine versus cosine, we have to know the parent tables are changing. For the sine parent table, it goes 1, 0, -1, 0. No, it doesn't. Snowman, remember? Oof. 0, 1, 0, -1, 0. So that one has the 3 zeros. For our cosine pattern, this is the one that starts off at 1 and has the pattern of 1, 0, -1, 0, 1. So they look slightly different. Sine waves, at least their parent functions, look different from cosine waves. These have been messed with by changing or transforming them with an amplitude change and or of a period change. So the amplitude, we're looking at the number in front of the function to see how it's changing our y values. So the amplitude would be +1/2. Okay. The period is going to be the opposite of whatever's happening down there. So the formula for the period is the one that's the hardest. That's 360 divided by b. So because b is 2/3, we're going to do the opposite of that. And when we say 360 divided by 2/3, we're actually going to take 360 and it gets multiplied by its reciprocal 3/2. Okay, so what would that be? 180 times 3 looks like it's 540. Okay. So when b was 2/3, we actually multiplied by 3/2. We did the opposite. Where it says graph here, we're going to go down and we're going to match it. But if we're looking at these values, even though amplitude is positive, we are supposed to multiply by -1/2 here. So the outputs would be 0, -1/2, 0, +1/2, and 0. And maybe just from that, we should be able to kind of see what's happening. So which one of these functions, first of all, can you tell which ones are sine waves and cosine waves? If they're starting off at 0, both of these have to be sine waves. And I know that because they started off at 0. Cosine waves start off at either 1 or -1, or their max or their min. And if we look at the entire period of the function, like this has one full rotation after 540 degrees. Okay. If I'd completed that table and multiplied each one of these by 3/2, 90 times 3/2, we can see like that would have been 135. $180 times 3/2 would have been 270. 270 times 3/2 would have been 405. So we can match that, and that's graph number 2. So I'm going to say like that matches graph 2. All right. Already, I don't even know that I need to go back and fill in all of this information to be able to match, but if we're looking at the amplitude would be 4, but I would multiply those numbers by -4 because that's the number in front of my sine wave. Okay, so we would be looking for a graph that's oscillating between the max and a min of 4 and -4. And has a period of 360 divided by 2 because of that 2 in front. So if we do 360 divided by 2, that period would be 180. And all of these numbers would be cut in half. Okay. So does that match what we see here for our sine wave? Is it cut in half? And does it do one full cycle after 180 degrees? Okay. For its amplitude, is it wiggling back and forth between 4 and -4? So that's graph 3, right? So that matches graph 3. And by default, like that should be graph 1. But we have to recognize that sine pattern or sine wave. We could have also looked at its amplitude. When there's nothing there, the amplitude is 1. So it's wiggling back and forth between 1 and -1. So these numbers wouldn't have changed. And the period of the function with that 3 theta in front of it would be 360 divided by 3, which is 120. And so hopefully we see after, like when is it reaching back to that one cycle? Is it reaching that one cycle but at 120 degrees? Because that's what a period looks like. It looks like when does it repeat? When does it repeat? Okay. All right. Now go do, you're finished with your ed puzzle tomorrow or later today if you want. Do the Google form that goes along with this homework and let us know if you have any questions.